Introduction to Boolean Algebra. Boolean algebra is a branch of mathematics that deals with variables that have two possible values, true or false. In the context of Boolean algebra, these values are often represented as 1, true, and 0, false. Unlike conventional algebra, which works with real numbers and arithmetic operations, Boolean algebra operates with logical operations. It plays a crucial role in computer science, digital electronics, and logic design. Basic concepts of Boolean algebra. Boolean variables are the fundamental elements in Boolean algebra, representing the logical states of true or false. These variables are used in expressions, often called Boolean expressions, to create logical relationships. Boolean operations are the basic operations performed on Boolean variables. The three primary operations are AND, OR, and NOT. AND operation, denoted by the symbol, or simply as multiplication, AB. The AND operation between two Boolean variables returns true only if both variables are true. In other words, A, B, B, 1 hot only when both A and B are 1. OR operation, represented by the symbol or addition A plus B, the OR operation returns true if at least one of the variables is true. This means A as B equals 1 in if either A or B or both are 1. NOT operation. The NOT operation is a unary operation that inverts the value of a Boolean variable. Denoted by a bar over the variable A or A, the NOT operation changes true to false and vice versa. Laws of Boolean algebra. Boolean algebra is governed by a set of fundamental laws that simplify expressions and help in designing logical circuits. Some key laws include 1. Commutative laws. These laws state that the order of variables does not affect the result of AND and OR operations. AB equals B will be 2. Associative laws. These laws indicate that the grouping of variables does not affect the outcome of AND and OR operations. A, B, C, C, A, B, C. 3. Distributive laws. This law shows how AND distributes over OR and vice versa. A, B, C equals A, B, A, C, stay minus, A, B, B, A, and a 4. Identity laws. These laws describe how a Boolean variable interacts with the constants 0 and 1. A, 0, 1 equal F. Null laws. These laws describe the interaction with the constants 0 and 1 in a more conclusive manner. A divided 1 equals 1, A d0 equals 0. 6. Idempotent laws. These laws state that a variable ANDed or ORed with itself is equal to the variable. A equals 7. Complement laws. These laws define how a variable interacts with its complement, not operation. Simplification of Boolean expressions. One of the main applications of Boolean algebra is to simplify Boolean expressions. Simplification helps in reducing the number of operations needed, which is critical in designing efficient digital circuits. By applying the above laws, complex Boolean expressions can be simplified to more manageable forms. Real-life use case. Digital circuit design. Digital circuits in computers and other electronic devices are built using logic gates. These gates implement Boolean operations. For instance, AND gate only outputs 1 if all inputs are 1. OR gate outputs 1 if at least one input is 1. Gate inverts the input, so 1 becomes 0 and 0 becomes 1. In real life, Boolean algebra is used in the design of circuits that control everything from simple devices like calculators to complex systems like CPUs in computers. For example, a simple traffic light control system can be designed using Boolean expressions. The system would use inputs such as sensors detecting the presence of cars and outputs to control the lights, yellow, green. By simplifying the Boolean expressions for these inputs and outputs, the system can be made more efficient and reliable. Applications in software development. In software development, Boolean algebra is used extensively in conditional statements. For example, In an if-else statement, the condition is evaluated as a Boolean expression. Based on whether the expression evaluates to true or false, the software decides which branch of code to execute. Boolean algebra and search engines. Search engines like Google use Boolean algebra in search queries. When you search using operators like and, or, and not, the search engine uses Boolean logic to combine or exclude keywords, refining the search results. For instance, searching for cats and dogs will return results that include both terms. Conclusion: Boolean algebra is a fundamental concept in computer science, electronics, and logic design. It provides the mathematical framework for working with logical statements and is integral to the functioning of digital systems and software. Understanding Boolean algebra not only helps in grasping how computers and digital systems work, but also enhances logical thinking and problem-solving skills.